Next, we want to look at the law of cosines. I've written it over here on the board. This is for any triangle ABC labeled like we usually label them. A squared is equal to B squared plus C squared minus 2BC cosine A. So the square of this side is equal to the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle between those two sides. Okay, or this is the angle that's opposite this side right here. Now, the same thing holds for side B and also for side C. B squared is A squared plus C squared minus 2AC cosine of B, where B is the angle between A and C, or the angle opposite side B. Now, if I take any one of these and solve for cosine A, cosine B, cosine C, then I get these three formulas right here, which are also called the law of cosines. Now, we use the first three if we're solving for a side, and we use the second three here if we're solving for an angle. So we would use these in the case where we were given all three sides in a triangle and needed to find one of the angles. We could use the law of cosines like this. So what I want to do now is some examples that involve using the law of cosines to solve for some of the missing parts in a triangle. Here we have triangle ABC, where side A is 410, side C is 340, and angle B is 151 degrees. Now I think since I have an obtuse angle here, I'll draw my triangle a little more accurately this time. Let's put in an obtuse angle. So here is angle A, angle B I have here, and it is 151.5 degrees. And there's angle C. Now side A, which is opposite angle A, is 410. Side C, which is opposite angle C, is 340. So I have here a side, an angle, and a side in this triangle given to me. That will allow me by the law of cosines to solve for side B. So what I have using the law of cosines is this. B squared is A squared plus C squared, the other two sides, minus twice their product, 2AC, cosine of the angle between them, or the angle opposite side B. Now, I'll substitute in for these, and A is, let's see, A is 410 squared, plus C, which is 340 squared, minus 2 times 410 times 340 times the cosine of 151.5 degrees. So A squared plus C squared minus 2AC cosine 151.5 degrees. That's the law of cosines. And what it says is the square of any side is the sum of the squares of the other two sides minus twice their product times the cosine of the angle between them. Now I can use this situation anytime I'm given an angle, a side, an angle, and a side in a triangle. And this corresponds to this information. Side, angle, side in this triangle will result in this kind of solution process. Now I've worked this out on a calculator ahead of time, and this comes out to be, let's see, B squared. When I do this arithmetic on a calculator, gives me 528,714. Then that's B squared, so I'll take the square root of that by using the square root button on the calculator, and to 3 significant digits, it's 727 meters. So I get 727 meters for side B right here. Now I want to solve for the other missing parts of this triangle, and what I need to do is solve for either angle C or angle A, one of those two. So I think what I'll do is solve for angle C first, and let's see, B is equal to now 727. I want to solve for angle C, so what I have is this. The sine of C is to the side opposite, 340, as the sine of B, 151.5 degrees, is to the side opposite, 727. Now when I do this solution process and solve for C, I'll get first of all sine C, and then from sine C, using my inverse sine button on the calculator, I end up with C equal 12.9 degrees. Now, the question is, I've used the law of sines right here to solve for sine C. Do I also have to check the 180 minus 12.9 degrees? And the answer is no. That would be an obtuse angle, and in this triangle, I already have one angle that's an obtuse angle. The last thing to solve for is angle A, and I won't do that right here, but you know that angle A will be 180 subtract angle B plus angle C. So I can do that, take care of solving for angle A that way. So here's a problem in which we use the law of cosines first to solve for one of the sides in the triangle. Once we had that, then we went to the law of sines to solve for one of the other angles. Let's take a look at our next example. Here's a triangle in which I'm given 3 sides and asked to find the largest angle. So I'll draw a diagram. Again, the diagram doesn't have to be accurate. It's just something that I can use to label the information that I'm given and the information that I'm asked to find. So if I label the triangle this way, side A is 38, so I'll write that in over here. Side B is 10, I'll write that in, and side C is 31. Now the instructions are find the largest angle in this triangle. Well, here I have 3 sides, 10, 31, and 38. Now the largest angle in this triangle is going to be opposite the longest side. So the largest angle in this triangle is going to be angle A. So I use the law of cosines this way. Cosine of A will be equal to B squared plus C squared minus A squared, all divided by 2BC. That's how the law of cosines goes when I use it to solve for the cosine of an angle. The cosine of A, it's the sides that A is included between first minus the side opposite A divided by twice the product of these 2 sides. So substituting in now, I'm going to take B, which is 10, and then C, which is 31. Subtract from that A squared, which is 38, all divided by 2 times 10 times 31. Now when I do that arithmetic, that's going to come out to be negative 0.6177 to 4 digits past the decimal point, cosine of A. Now that's what's nice about using the law of cosines to find one of the angles. If your angle is an obtuse angle, that is the angle terminates in quadrant 2 or is bigger than 90 degrees, the cosine of it is going to be negative. So there's no ambiguous case to go with this like there was when we used the law of sines to solve for one of the angles. So if I press the inverse sine button now on the calculator, what I'll get for this angle is 128 degrees. So the largest angle was angle A because it's opposite the longest side. I use the law of cosines this way, substitute in, I get a negative number right here telling me I'm going to end up with an obtuse angle, and sure enough with my inverse cosine button on the calculator it comes out to be 128 degrees. Next I want to do a couple of application problems that also use the law of cosines. Here's our first one. 2 planes take off at the same time from an airport. The first plane is flying at 246 miles per hour on a course 135 degrees. The second plane is flying at 175 degrees, that's the course, at 357 miles per hour. Let's assume that there's no wind currents blowing. How far apart are they after 2 hours? Well, first of all, I'm going to draw in my north-south line. And then this will be the west-east line, like this. Now, the first plane is going at 135 on a course of 135 degrees, so that's directly down this way, and it's traveling at 246 miles per hour. So this is 135 degrees, so this is going to be 45 degrees right here. Now the second plane is on a course of 175 degrees, and it's going 357 miles per hour. So that plane, I'm just going to draw this in approximately, is on a course that is 175 degrees. This one was 135 degrees, so this difference in here is going to be 40 degrees. Now I want to know how far apart these planes are. That is, what is that distance x after 2 hours? Well, my one plane is going 246 miles per hour, so 246 miles per hour times 2 hours, that's going to give me, I think, 492 miles this will have gone. So 492 for the length of this side right here. The other plane is going at 357 miles per hour times 2 hours. So that will have gone 714 miles. Now does that sound right? 2 times 6 is 12, 2 times 4 is 8, 9, 2 times 2 is 4, 492. Okay. So you can see now by the law of cosines, I'm looking for the length of this side of this triangle. This side is 492, this side is 714, and the angle between them is 40 degrees. So that's a case where I'm given a side, an angle, and a side, so I can use my law of cosines. So we'll do that, and this time I'm going to do it with a square root. X is equal to the square root of 492 squared plus 714 squared minus 2 times 492 times 714 times the cosine of the angle between them, which is 40 degrees. So I'll work all this out on the calculator, take the square root of what I get, and the answer comes out to be x equal to 3 significant digits, 462 miles. So after 2 hours, these two planes are going to be 462 miles apart. The first plane is on a course with a direction of 135 degrees from due north. It's flying at 246 miles per hour, and it flies for 2 hours. The second plane is on a course that's 175 degrees from due north. It flies at 357 miles per hour for 2 hours, so it flies a total of 714 miles. So after 2 hours, the distance they are apart is represented by x in this diagram. I can solve for it very easily using the law of cosines. It comes out 462 miles. The next problem we want to do also involves the law of cosines. Let's take a look at it. This is another airplane problem. We have a plane with an airspeed of 175 miles per hour and a heading of 30 degrees. So 195 miles per hour, sorry. Airspeed of 195 miles per hour and a heading of 30 degrees. So let's draw in here my north-south line. I'm going to put in the west-east line right here. So this first plane is on a course of 30 degrees. And it's flying, so this is 30 degrees right here, and it's flying at 195 miles per hour. Okay, now the ground speed of the plane is 207 miles per hour, but the true course is 34 degrees. So the plane is headed in a direction 34 degrees, but the wind currents are blowing it so that its true direction is 34 degrees at 207 miles per hour. So I'll exaggerate this drawing a little bit. This is 207 miles per hour. This is 34 degrees. That's 30 degrees. So inside here is 4 degrees. Find the speed and direction of the air currents, assuming they are constant. Well, that's going to be this vector right here. First of all, we can find its magnitude, or the speed of the air currents. That will be, by the law of cosines, x equals the square root of 195 squared plus 207 squared minus 2 times 195 times 207 times the cosine of just 4 degrees. Now I've worked that out on a calculator, and let me see what I got for that. It comes out to be x is equal to 18.5 miles per hour to 3 significant digits. So that's 18.5 miles per hour. Now I want to know what the direction of the air currents are, and so I need to know what angle, let's say this is down from due north. So to find that, I need to find this angle in this triangle. So I can do that with the law of sines. I can solve for this angle because I have the side opposite it, and then I have the ratio of this side right here to the sine opposite it. So I can use the law of sines to solve for this angle right here if I want to. I'm going to leave that for you, though. I won't go ahead and do that. But it will involve using the law of sines and drawing this diagram maybe a little bit more accurately so you can see what this angle is down here from due north. So again, here's where we use the law of cosines to find the side in this triangle using this big square root. Once we find that side, then we can find the other angles in the triangle using the law of sines instead of the law of cosines.